And I've got there's a page on there that says Dan Dudley and Associates. I guess I'm in, huh? Okay, hey, what's your address and tell me how much can I send you a check or how can I pay you? Okay, thank you, sir.
Should pull that down. Got more of it.
513 203. Yes, sir. I appreciate it. Yes, sir. I appreciate it. Yes, sir. Yes, sir. Starts in 17 minutes.
So yeah, you can get out of this one, hop into that one.
Yes, sir.
ABC. Let's do a quick recap. Class A extinguishers will put out fires in ordinary combustibles, such as wood and paper. Class B extinguishers are for use on flammable grease, gasoline, and oil. Class C extinguishers are suitable for use, not electrically energized fires. Class D extinguishers are designed
You can always read it.
combustible metals. Class K extinguishers are designed
Can you hear me okay on that end?
woods and greases. Small fires can usually be brought under control if they are attacked within the first 2 minutes using the right time and right size for extinguisher. If employees are trained to use portable fire extinguishers to fight small fires, an employer shall ensure extinguishers are accessible to the working crowd. Fire extinguishers should be located so that the employee working there to any extinguishing agent is 75 feet or less. To help ensure fire extinguishers
Right here's where you mute.
It looks like we're getting pretty close to time to start. Can everyone hear me out there?
Yes, sir.
Good deal. Thanks, Ronnie.
Yes, sir.
We can hear you just fine here in Phoenix as well.
Good morning. Thank you. As we're getting ready to start here, if you don't mind, go to chat and put your name in the chat for me and the company you work for. That's how I make sure I can prove you're here today. You know how to do that?
Le-
At the very bottom of your screen is a icon on the menu. It says chat. Just click it and it'll bring the chat window up. Thanks, Phoenix. Thanks, Steve. Daryl, Donnie, thank you. Looks like we're pretty much all here already. Oscar, and make sure here. Adam, Oscar, Omar.
They're not doing it in person anymore. Okay. Only hands on. That's the only thing that's done in person anymore.
Y'all ready to get started?
yes, sir.
You should have received your class workbook. Looks like this right here on the side. And you will need the consent form, which I've got right here. I'll answer the consent form with the hands-on Friday. We have hands-on for the class Friday. I'll show you where to go in a minute. But at the end of the class, how to pick your time for Friday. Okay. That class workbook's got a lot of things in it, more than just a class. It's got all the slides in the class in it. It's also got things like let's set your work permit for energized work. It's got a lot of other things in it for you. So it's not just a class. It goes through a bunch of things like meter safety from Fluke, including that workbook also. So there's a lot of things there for you for after the class in that workbook. If you've got a camera, unfortunately, the camera's got to be on. If you don't have a camera, I'll be asking a lot of questions. You're going to have to give me some kind of response. I'll know you're there. My class is open to anyone from anywhere in the country who wants to log into the class at any time. I'll send the login information out freely. A lot of guys want to see what I'm doing, how I'm doing things before they hire me to do training. I have different people logging in and out all the time in the class. XTO logs in and out, Exxon logs in and out, Oxy logs in and out. You can see what we're doing. Okay. They've seen people a few times driving down the road on a phone trying to take the class driving down the highway. It don't work very well. Okay. So if you have a camera, camera's got to be on. If you don't, you have to show me you're here on a regular basis. Just a heads up to you. At the bottom of your screen is a menu where the chat button was. Also, you can mute your microphone, turn your video on and off, things like that. Be aware of your mic. If it's on and you get to an argument with your wife or somebody out in the background here, we're in the class going to hear it. So be kind of alert and aware of your microphone. Okay. The class can be translated into Spanish or any one of 70 other languages now on the fly. There's a way to translate it. Go to more, the three dots on points on the top of the screen, click on captions, enable translation, pick a language. So if anyone needs it in Spanish, this is the way to translate it on the fly as we go. Which is why I use Zoom and not something else. It'll do live translations for me that are fairly accurate. Okay. There's also heart emoticon on that menu for you. It's not on my menu, but it's on yours. Those are what they call emoticons. Little symbols you can throw at me. Okay. If your camera's not on and I'm asking a question, you can't show me your camera that you're there, throw me a thumbs up, a thumbs down, a yes, no, or something like that. Okay. That lets me know you're still here and still engaged in the training. Okay. So how about pick one of those emoticons right quick and show me how to use them. That way, when that comes up, you can respond somehow to questions and things. Any one you want to use, it doesn't matter. Throw one at me or something. And there you go. Thanks, Steve. Okay. If I can see you on video, you say yes, no, or throw a thumbs up at me. But I'm required to make sure you're here the entire time. So that's part of all this. My contact information on the screen. Several ways to contact me. I do respond to calls and text messages and emails. It may not be immediately, but I do respond to them. And I'll leave that up there for a minute in case you want to copy it down, take a picture of it, what you want to do with it. I'll bring that up again at the end of the class also in case you decide you want it later. If you did not get the class material for some reason, I got a few ways for you to get it. You can go to my website. The easiest way to get to that website is dandudley.com. You can write, this is where you're going to go, but this is the easy shortcut to get to it right there. Okay. Top button right here says Electrical Safety Class Materials. Click it. It'll take you to another page where you can pick what you need as far as materials go. Login information is there, class workbooks are there, answer sheets there, everything else is there for you. Okay. Or you can send an email to me, just dandudley.org. Put NFPA 70 exactly as it is here in the subject line. And then 2 or 3 minutes, they'll send back to you all that information by email and as attachments. Okay. If you space out NFPA 70E, it's not the same thing. That guy did that yesterday. Okay. Exactly like I'm showing it, capital letters in the subject, and it responds to you really well. So if you didn't get anything, that'll send it all to you really easily. This is the class survey form and evaluation form. There's one that'll come back to you by email if you send it that way. I'll have several of these in my trailer for you also. It's anonymous. It is your way to give me your opinion of my training. Okay. All comments are welcome, good, bad, and ugly. Okay. There's plenty of lines on the back of that page. You write whatever you want. If I do good, I enjoy hearing it. If I do bad, I need to hear it. And if you have improvement ideas, I'd like to hear those. You may think of something I didn't think about. So all comments, good, bad, and ugly, are welcome. After the training, probably Sunday morning or so, I'll send back to your company documentation of all the training. And depending on what we do in the training, particularly the hands-on part of it, there may be one or more certificates in that documentation. There will be several forms similar to this form right here. Okay. This is my classroom training form. Every topic we discuss in a class is documented on this form. Everything we talk about. Okay. That's how detailed the training documentation is on the form. There'll be several of these, even if you only get one certificate, there's several forms come back with it. In the middle of the screen is my wallet card. It's a hard PVC card, like a credit card that I print for you. You get a new one of these every time you go through training. All your information is updated on that new card. Okay. I'll give you that card and the hard hat stickers and all that at the hands-on training when we're done there. Okay. This is a refresher class. That means you've already been through one of my classes before. My licenses, do they qualify me to do anything? Yes or no? Do they qualify me? Thanks, Steve. Do you remember? Thanks, Daryl. Good deal. What do they do then? Do you know? By the way, they're all current. I keep them current. That's my contract's license expires next year. Master license also expires next year. New Mexico, 2026, 2027. So they are current. What do they do for me? I'll carry them. So I don't scan them every class, but what do they do for me? You know, you can take your mic off mute and respond audibly. We can hear you.
Show that you've been trained.
Okay. Here's the back of that master license. Do you see the word certified or qualified anywhere on the back of that license? It's not there, is it?
No, sir.
Texas does not certify me or qualify me to do the work. They're authorizing me. See that third line down, first word says authorized.
No.
That's all they're doing. They're authorizing me to do the work.
Yeah.
What they're saying is because I satisfied the state of Texas requirements to hold that master license I showed you a while ago, they're authorizing me to work under the scope and category of that license. That license up here in the top right side. Okay, that's the back of that license you saw. Okay. They're not saying I'm qualified or certified or they've checked me out and none of that. They're saying I satisfied their requirements with time in the trade, people signing off of my experience and passing their exam to hold that license. And because I hold that license, now I'm qualified to work under that license. They're not saying I know what I'm doing in a residential wiring environment, a power line environment, commercial environment, industrial environment. None of that's there, is it? OSHA says that license is, quote, an indication I might be qualified, unquote. So they'll look at it. That'll be one part of the documentation or cog in the wheel, so to speak, but that's not enough for OSHA. Okay. My licenses are state level requirements. In this case, for the state of Texas, New Mexico, and Oklahoma. Okay. I've cut all my licenses down to just those 5. Okay. Federal law is OSHA regulations. Federal law trumps state law. Federal law says these help with the qualification. That might be qualified. Other things required. What else is required to be qualified? Do you remember? If that doesn't do it, what does? That's what this entire class is all about. You're either qualified to do something or you're not qualified. There's no gray area. There's no middle area. You either know what you're doing or you don't. It is knowledge, skill, training, and experience. That's what qualifies you to do the work. So a piece of plastic here doesn't prove it. Part of being qualified is knowing the requirements for what you're doing and actually following those requirements. It's a very big part of being qualified to do the work. When I do power line training, particularly bucket rescue training, about every 5th class or so I do now, bring my drone out. I put it about 50 feet above us in the air. I turn the camera down, get a bird's eye view of the training, about 30 minutes or so. I'll bring it down, I'll change the battery. I'll put it about 20 feet in front of us, about 15 feet in the air, at a little bit of an angle looking down at us so I can get a better shot of the training, particularly block and tackle rescue. A student told me about 9 years ago now, I need a license to fly that drone above my own training. I said, bullshit, I don't believe you. He said, no, he was serious. And he showed me his license. Okay. On the off chance he was correct that I did need one, I thought I better contact the FAA and make sure what was clear, what wasn't clear. I called the FAA in Lubbock. I came down on a Saturday, watched what I was doing for a couple hours. Told me, yes, sir, you need a license to fly that drone. Would you believe at 62 years old, I'll be 70 here in January, I had to go study to be a pilot, pass a pilot exam to fly my drone 50 feet above my training. Would you believe that crap? Yeah. When I was taking my exam in Lubbock at the airport, there were 4 other commercial pilots taking their test. They have to retest every 2 years. They got done. They started before I did and got done before I got done with mine. Okay. They were looking over my shoulder at my exam, and they allowed me to look at their test as higher level than mine is. Okay. When I got done, they said, you know, every question we saw on your exam was exactly the same question on our exam. Only difference was you had 20 less questions than we did. I don't know, weather patterns, runway patterns, etc., everything like them. Okay. That was 2019 when I took that the first time. You renew it every 2 years. They don't issue the card to you again. They issue to you a certificate showing you renewed it. Gentlemen, give me a minute. I got somebody banging on my door. Hang on just a second, please. I'm banging loud on my door outside. Sorry about that. Sorry about that. My wife locked herself out of the house. Sorry about that. They issue this certificate to you every time you renew the license. So if they ask for your license, you pull a small copy of this out, like a license size, and the original license. That's how they do it. Okay. I renewed it in February 2024. It's due again here in February 2026. I'll renew it again in 2026. Okay. This is something I completely disagree with. I don't fly above 100 feet at the most. I fly above my roof after a hailstorm, and I fly above my training. That's all I do. I can't stand 50 feet in the air, hold that camera, and do the train at the same time. All that drone is to me is a pair of hands holding a really nice camera. That is all it is. That's what I've got it for, and that's all I use it for. Okay. Every time I fly my drone, I got to file a flight plan electronically. I've got to get permission to FAA to fly that drone. You know, it's a lot of headaches in a lot of ways for what I do with it, but it's required. That is the law. That's the FAA regulations on it. Besides the penalty is $15,000 now for not having a license flying it, but it is a requirement. Okay. A big part of being qualified to do the work is knowing what's required and actually following and doing what's required. It's a big part of it. Okay. Like it or not. And I totally disagree with that on my part. Like I said, I'll renew it again here in February next year. Okay. This class is based on NFPA 70E. It's a standard for electrical safety in the workplace. Okay. This standard covers the rules for you and I doing the work to try to keep us safe. That is what it's all about. The threshold for survival injury in 70E is a second-degree burn. I'll explain to you why that's a threshold in a little bit. but that's the threshold. If you're following the rules in 70E, you should not get anything worse than a second degree burn. That's there's baseline, their standard. Okay. So all the rules in there are designed to prevent any worse injury than that to you, provided you're following those rules. You can't eliminate all possible injuries, but that one you should survive. It's got a high survivability rate. Okay. 70E works with 70B and NFPA 70. They all three standards work together. NFPA 70 is an electrical code that protects people and property from the work we're doing, from fires and burning things up and blowing things up. 70B is a maintenance standard for equipment. Okay? And 70 is a safety for us doing the work. Okay? They all three work together. What I'm not going to do today is read NFPA 70 to you. I'm going to teach you how to do the calculations. You're not qualified to do the calculations. There's no reason to teach you stuff like that. Okay. I will go through the entire standard here with accidents and pictures of accidents, things like that, and say what they should or shouldn't have done and what the outcome should have been. Okay. If there's an injury involved in something you do on the workplace, what happens to the insurance? Have they ever told you that? Particularly if you're the one that called the fault, it's your fault. What happens to your insurance? And by the way, this includes workman's comp.
Oh, no.
It goes away. You know, if it's your fault, so they can pinpoint the finger at you and say it was your fault, you don't have any insurance effective when it occurred. If they've already paid for care for some reason in the hospital or something, they're going to want it back from you. And they will seek it back from you. They'll don you and bill you and harass you till you pay some of it back. So if it's your fault, the insurance goes away. This standard covers three areas: safe-related work practices, maintenance requirements, and special equipment. That's all it covers. It's a little over 350 pages long, not very long standard. It only covers three areas. What's maintenance like in the field? What's that like out in the field? Is it good, bad, or ugly? Ugly usually. I like that one. You do JSAs, correct?
Yes.
You do a written JSA, hopefully. It's got to be documented. OSHA says documented, which means written down somewhere, not mentally like some companies are trying to do. I got a few companies trying to do a mental JSA, and that'll bite them pretty soon, probably. OSHA says it's got to be documented. On that documented JSA, you're supposed to evaluate the status of your equipment. As far as maintenance goes, are you doing that? Because the maintenance status of the equipment can enhance the possibility of something going wrong or make it less likely for it to go wrong. Which when you figure in that JSA's job safety analysis or job hazard analysis, JHA, you're looking at the likelihood of something going wrong in the process of doing the work. That's what that JSA and JHA is all about. What are the likelihood of something going wrong? You have to account for the maintenance status. Okay. If you never change oil in your truck, what's going to happen? You buy a brand new and never change the oil. What's going to happen? Something's going to screw up, isn't it? Can you predict when?
No.
Can you predict where you'll be when it occurs?
No.
Can you predict what or how it's going to occur?
No.
Those are all unknowns, aren't they? Same thing's true with our equipment. If you don't maintain that equipment, it is going to fail. You can't predict what part or how it's going to fail, when, or what you'll be doing when it fails. It will fail. Okay. All these companies claim to do maintenance. I've seen maintenance schedules out my ears of different companies. Okay. They got PM schedules everywhere. The problem is there's never enough time, people, or money to do maintenance the way it's supposed to be done. Okay. I've been in the field 48 years. I've never had a single contractor I work for send me out to only do maintenance. Not one time in 48 years. I worked on power lines, substations, chemical plants, a lot of different areas. Not one time I only to do the maintenance. I've been sent out to fix a problem, put it back in service, and been told, hey, while you're there, if you got a little extra time, take care of some of the maintenance. I've been told that several times. But never one time have I been sent out to only do maintenance. It doesn't get done that way. Okay. Even on shutdowns and turnarounds in plants, they hardly ever did all the maintenance. They did quite a bit of it, but hardly all of it didn't get done. I want you to understand the maintenance problem we got out in the field out here, what it affects. Are you seeing these labels more and more? They're more and more predominant, aren't they? They've been required since 2000, by the way, 25 years ago, when they started being required. We're just now seeing them, a lot of them now, past 4 or 5 years or so. On this label is a section called incident energy. Right there. That number on that label, that incident energy, controls everything. Your distances, your boundary, your PPE, it controls everything. Okay? To calculate that number, you've got to assume the maintenance has been done on your equipment 100%. You got to assume that to do the calculation. There's no way to do it without assuming that. This is what they mean by the maintenance. Now bring this up so you can see it here. This blue panel is out of NFPA 70's handbook. It explains what they mean by maintenance. Properly maintained in accordance with the manufacturer's instructions, which no one ever reads, and industry codes and standards, which is 70B. Then, when's the last time you read the maintenance instructions on the equipment? When's the last time you read the instructions with a piece of equipment?
Never.
Yeah, most of the time it goes in a trash can box. You know, when I was a journeyman, before I became a foreman anywhere, working anywhere, when I was just a journeyman carrying tools, I read instructions when things didn't go right. If the installation didn't work out right for some reason, then we went to the instructions. When I became a foreman, I realized I better read the instructions as a foreman. Because when the crew has a question, I better know how to answer that question. Okay. When I became a contractor, it became very important reading instructions. Okay. But normally, as a journeyman carrying tools, I didn't need the instructions, right? No one really reads them. Okay. The maintenance requirements for the equipment's always been in manufacturer's instructions. I go back to 1964 equipment instructions. Maintenance requirements are there. Okay. Here's the problem with this situation. The number on that label cannot be accurate. I've talked to 9 power engineers now in 6 years about this situation all across the world. I did train before COVID all over the country and all over the world. I talked to 9 different power engineers that do these calculations themselves, and they've all told me the same thing at the end of the conversation. So they take the worst case scenario at that equipment and add some to it to account for lack of maintenance. The problem with that is that number they add to it is completely subjective. They're adding between 10 to 20% on average to worst case scenario to try to account for lack of maintenance of the equipment. That means this number right here that you're relying on for your PP and everything else is their best guess. And all 9 of them told me that was true. So here's a challenge. Any electrical engineer that wants to discuss this with me, you got my number. Prove me wrong.
4326.
Prove I'm wrong. They're going to give you, for this label right here, a 40-calorie suit. I guarantee you that's what they'll give you for protection. If that number is not correct, that suit may not protect you. It may not be enough. So I've got 9 power engineers that back me up on this now. That the number on that label, no matter who puts it on that label, it has to be a guess. Challenge anybody to prove me wrong. My number's toll free. Prove me wrong. Show you a really good label right quick. What's about labels here? We'll get your attention on that label. Besides that faded out red danger up there that's supposed to get your attention to start with. How about no safe PP exists? Energized work prohibited, which means not allowed. Do not work on live. 4 times under PP ratings. That ought to get your attention. Okay. They've got 180 calorie per centimeter incident energy here on this label. The highest score I can buy is 140 calories. And that 180 calories per centimeter squared is not the top end possible on this label. Right below it, it says 40 to 999 calories per centimeter square, flash risk range. I've only seen that 4 times in 20 years on live equipment. Okay. This particular equipment powers up 5 buildings, 4 horizontal pumps on the surface, and 4 or 5 submersible pumps. So based on the load on the system at the time it explodes on you, has an arc flash, it might be 1,000 calorie exposure. If it's sunny morning, 2 o'clock in the morning, night lights only, minimum equipment operating, maybe as low as 40 calories. The average is 180 calories. On that label, that's what the 180 calories represents, the average of the load. Okay. A working distance is 18 inches. You know why it's 18 inches? Do you remember why it's 18 inches?
Is that as far as you can reach?
That's where your chest is when you're working on equipment. Whether you're on your knees on the ground, on your bucket, on a ladder, standing up working on equipment, wherever you are, when your hands are working on the equipment, your chest is 18 inches away. It may vary 2 or 3 inches, not very much. Yeah. So that's what they consider the average working distance. That's to your body. Now, where your hands are, that's to your body. Okay. So everything is based on 18 inches here. Okay. Now, flash risk boundary right above that is 383 inches. It's just shy of 32 feet. Okay. That's my measuring wheel, my rolling wheel. Zeroed it by the door, rolled out 32 feet in a straight line, ended up in the 5th space of the parking lot, 32 feet out from that door. That means if I'm in the 5th space of the parking lot, the window rolled down, wear my t-shirt I'm wearing right now today, and that cabinet had an arc flash event, I could get a 2nd-degree burn 32 feet away in my truck from thermal heat. You know what thermal heat is? Because these boundaries here are all based on thermal heat. The heater vents in your home put out thermal heat, heated air, usually under 200 degrees Fahrenheit. Okay. If I could stand you at that heater vent and not let you move, over time I could cause a 1st-degree burn. Eventually I could cause a 2nd-degree burn. If you stood there long enough, even though it's below 200 degrees Fahrenheit, I could cause a 3rd-degree burn. Time, temperature, and distance. High time, low temperature equals high temperature, low time. So time, temperature, and distance, how far away you are. That determines the outcome. Okay. So what do they tell you to do when your clothes catch on fire?
Stop, drop, and roll.
Everywhere I go, stop, drop, and roll. Okay. Do they ever tell you when it won't work or when it's not a good idea. Did I ever tell you that part in the class? I don't ever hear that part, do you? In fact, I've asked an instructor a while back, I said, what about this? What about that? He said, stop, drop, and roll. That's all he could tell me. So that's what's in the book. Okay. What if there's flammable contamination on the ground, oil or something else that's flammable? It'd be a very good idea to roll around close to it or in it. Not a very good idea, huh?
Worse.
So if I'm on concrete, would that be a good idea? Would that put the flames out?
Hope not.
Not going to do it. I need soft dirt, 3 to 6 inches of soft dirt, preferably to put the flames out. How often are you standing in 3 to 6 inches of soft dirt doing the work we do?
Never.
Usually not very often. I'm on gravel, I'm on hard packed dirt and caliche, on concrete, or elevated off the ground. About a third or more of the time I'll be doing work out in the field. You know. So concrete won't help you, gravel won't help you, hard packed dirt and caliche is not going to help you. Okay, concrete definitely won't put it out. I need to smother the flames. I need to deprive the flames of oxygen. That's how you put a clothing fire out. You deprive it of oxygen. Blanket, a jacket, a tarp, something like that'll do it. Other than all, that's usually what you're standing on doing the work. Either gravel, concrete, or packed dirt, caliche, something like that. What if I'm 40 feet in the air? Or on a 12-foot ladder? Or on a scaffold? How do I stop, drop, and roll? It's kind of hard to do, isn't it?
A long way down.
A man in the bucket here is wearing a harness and a lanyard. Okay. Here's his harness. Here's his lanyard, hopefully tied off to the bucket. Okay. That is PPE, also known as fall protection. Why are you required to wear a harness and a lanyard in a bucket, on a scaffold, on a scissor lift, or on a ladder?
But they don't hit the ground.
What's it designed to do for you?
Keep them falling.
Can't keep you from falling.
Will keep you, it keeps you from hitting the ground.
Thank you. There's two different things.
Yeah.
One thing's designed to keep you from falling. That's not what this is. Or designed to keep you in the ground if you do fall. Okay. A harness and a lanyard is designed to keep you in the ground.
Hello?
Not keep you in the bucket, not keep you on the ladder. Okay. Can you be injured using that fall protection?
Yes.
Definitely could be injured using it. Yes, sir. Here's something I keep seeing people, particularly people don't wear harnesses very often. This chest strap right here goes sternum level, nipple level or sternum level. Okay. If you have it any higher than that and you follow that harness and the harness shoulder straps are a little loose on you, this can end up right around your neck and your own body weight can choke you to death while you hang there. Okay. Particularly on one where you can't move that chest strap up and down easily. You've got to adjust it. So be careful wearing harnesses. Make sure that chest strap is down where it needs to be. And then make sure your shoulder straps are nice and snug. How about setting equipment up close to power lines a little bit? This is a boom truck or a winch truck, depending on where you're at in the country, what they call it. In front of this vehicle is a 69,000 volt power line. He's going to set this rig up with that across from him. And what I look at are two things when I'm setting equipment anywhere close to power lines. Maximum reach of my equipment, number one. He's got a 40-foot boom. He can boom out 40 feet from the middle of the pedestal. So I'll start with the 40-foot possible reach. I've got 20 feet and 10-foot buffer zones. To use the 10-foot buffer zone, I've got to have markers on the ground in front of me. I know right above that is my line, or someone on the ground watching me, keeping me clear. One of the two. If I don't have either one of those, I cannot use 10 feet. I've got to use 20 feet. In that case, I've got my 40 feet. I've got my 20 feet, which means I set the rig up 60 feet in this case to the middle of the pedestal to the power line. That's my measured distance. Okay. The operator on the rig didn't do that. He planned to use 20 feet of boom only. So he started with the 20 feet he planned to use instead of the 40 feet he should have started with. He took 20 feet, decided he wanted to use a smaller buffer zone, the 10-foot buffer zone, put that in there, and set the rig up 30 feet from the power line to the middle of the pedestal. Okay. That's half the distance that he really needed. Okay. Halfway through the project, he decided to boom out the remaining 20 feet, but he's not set up for that. Okay. If my boom is laying horizontal, and I start at 20 feet and add 20 feet to it, the cable is going to move 20 feet additional. Okay. He's not horizontal though. He's at a 70-degree angle and started at 20 feet, added the remaining 20 feet to it. The cable's going to move, it's not going to move 20 feet. Okay. The calculation says about 12 and a half feet. If he's truly 10 feet from the power line at 20 feet, and he's going to boom out 20 feet and move the cable 12 and a half feet, what's likely going to happen?
With power line.
Make contact with that power line. Okay. The operator was an ECCCO certified crane operator, which means he knows how to do the calculations. He's got to do those to pass that NCCCO test. Okay. He didn't do any of that. He boomed on out when he changed his mind and made contact with the power line. I'll stop it on the contact and let you see the contact here.
Like our welding. Just like our welding. We won't actually burn them or anything. We won't actually burn them or anything like that. Yeah, it is.
Any idea what the breakers or fuses aren't opening? Any idea why the power line breakers or fuses aren't opening the circuit up? We're not grounded, number one. He set up too close, number one, but we're not grounded, number two. Had he grounded the rig, went from the rig itself to a ground rod, took that to the closest pole ground, and trip him out immediately. We don't have a very good ground.
Hey, Frank, the truck's moving.
We'll get a better picture of the contact here in a better. Yeah, not quite there. You get a better picture of power line contact. He's way too close. Had he set the rig up 60 feet away like he should have done to start with, it could have fell and not contacted the power line. Which is why they want that distance there. Okay. When he changed his mind, when he decided to boom out the remaining 20 feet, that should have changed his JSA, shouldn't it?
Yep.
What should he have done?
No.
And reevaluate.
Evaluate it.
When you do JSA, then you have to do something like that. In case no one's ever told you this in a JSA class, do not cross things out on the original JSA. If something goes wrong that day, like happened right here, all those JSAs are going into court. You start crossing stuff out in the JSA, that proves whoever did the JSA was not qualified to be doing the JSA, which means you didn't do a JSA, which is an additional problem on the case. Okay. Take a new JSA, copy what's applied to the new one, and fill in the rest of the notes on it. Don't cross stuff out on the old one. It will bite you eventually. Had he set it up correctly, none of that would have been a problem, would it? He got lucky, he jumped in rain, he got away, burned the rig to the ground, Bo. Not his rig, though. What does it matter, right? I'm going to put my helper where he shouldn't be. Right here.
Inside the cab.
What's he going to do? What's he going to do?
Jump with both feet together?
He's got to. Well, right now he can't jump. The door's closed.
No.
There are some times you got to think logically in the right sequence. If you don't do that, it'll get you. So he's got two choices. Number one, he can sit there and be burned alive. Eventually, it's going to happen. Or you can come out of that rig, right?
Yep.
Okay. I've been told for years that 99.8% of the population won't sit there and be burned alive. They'll come out of that truck. So pretty.
Yeah.
Here's the question. How does he get out of the truck? First, how does he get out and get away?
He's got to jump as far as he can.
You got to open
Open the door, right? First thing I got to do is get the door open. How to open the door?
With his foot.
Sir? I didn't quite understand what you said. I'm sorry.
Yes, they have all the gloves.
With the, he got a PPE on, otherwise he could get started off. He's got to open it with his foot or something.
Well, here's the problem. In front of that truck is 69,000 volts. That's what's on the main power line face to face. One face to ground is 39,800 volts. That's what's going through that truck right now. That's also what's going through that helper in the truck. He's energized also at 40,000 volts. What I don't want to do is have more than one point of contact at different voltages. Okay. That's what kills you and causes current flow. Okay. Think about a bird on a power line for a minute. Power lines between poles are not insulated. If they've got a cover on the wire, it's weather protection and sunlight protection only. It's not insulation. But if you land on it or touch it, you're touching a live line. Okay. That bird's landing on a live line, is he not?
Yes.
And he's got 2 points of contact. Why is he getting hurt?
Because it's only touching one wire.
They're both at the same voltage level.
Yeah.
There's no difference. Okay. If you hop over to a ground wire on that pole and fix that ground wire, feathers will fly, it'll kill him. He takes off and touches two phases with his wings, it'll kill him. But he hops around that one power line, jump over each other, play. They do what they want to do. Leave and come back and land, and no problem, right? As soon as he lands on that power line, he is energized at line voltage. But both points of contact are at the same voltage level. Okay? If I try to use my boot or a pair of gloves or the floor mat on the truck, it's going to cause the hand on the door handle to be at a different voltage than my feet. Two or more points of contact at different voltages causes current flow. Current's what destroys your organs, burns your organs, and sets you on fire. You don't want to try to insulate your hand, even though that's kind of intuitive to electricians. Okay. Encore, TXU, FPS, New Mexico, all these utility companies, local utility companies, have PSAs, public service announcement ads on TV. They're showing an old couple driving down the highway, having a wreck, hitting a power line pole, power line breaking and falling in the car. Okay. Next thing they show is them hopping through the car and scooting and hopping away. They never show them opening the door in the ad. Next time you see an ad, look at it, watch it. Okay. I caught an engineer at TXU a while back and asked him, I said, why don't they show how they open the door? He said, you must be an electrician. I said, you got me. He said, the problem we have with an electrician is we think about insulation all the time. That's in our mind, insulation, insulate against damage. Okay. He said, the old couple on the ad, they're not electricians. He wasn't an electrician. He's an old retail clerk. She's a retail clerk. He worked in a bar. She worked somewhere else. They're just normal people. All they know about electricity is plug a cord in, make coffee or whatever. That's all they know about it. Okay. How do you think they open the door of the car?
Grab the handle and open it.
Same way they got in, barehanded on the handle. Okay. That is the safest way to do it. My helper in the cab of that truck right now, his feet are at line voltage. If he's sitting on the seat, his butt on the metal springs on the seat are at line voltage. He doesn't want to do anything at all to change that with his hands. That door frame, and door handle are also at 40,000 volts. His hand is at 40,000 volts. Right now, he's a bird on a wire. He can safely unlatch the door, push the door open to hop clear. Okay. Don't try to put your gloves on or the floor mat off the truck or something like that. That'll change the voltage levels. Okay. Once my door is open, I need to jump clear, right?
Yes.
How far?
As far as possible. As far as possible.
Okay, that's what everybody thinks. I've got a small problem on the ground, though. It's called step potential. At the tires and outriggers on the vehicle. My tires and outriggers, okay? I've got 39,000 volts right there on the ground. As I get away from that contact point, I'll get different voltages in the rings like you're seeing right here around that contact point. Think about throwing a rock in a pot of water, underwater, okay? I throw the rock in the water. At the impact point, I've got a lot of little waves real close together, high close to it, lower in elevation as it gets away from it. The further away I get, the further out my rings are, right? My waves, and they're lower. Between the waves, we're the same voltage. If I have 1 foot here, 1 foot here, though, 1 foot's at this voltage, that foot's at a different voltage. That causes that current flow situation, okay? In the water, I can see where the waves are. I can see where it changes, can I?
Yeah.
On the ground, there's no telltale sign. I can't tell where it changes. But it does exactly the same thing that rocking upon the water. The rock's my power going to ground. The rock's in the water doing the same thing that power is doing. Radiating out from it are different voltage rings. Okay. What I don't want to do is jump too far and stumble or fall on the ground. Then I'm laying across these if I'm on the ground. I can have 1 foot at one voltage, another foot at a different voltage, an inch apart. When I land, I need to land on the ground with both feet touching leather to leather. Leather is conductive. Right here, I'm a bird on a wire. Both feet will be at the same voltage level at all times. Okay. I don't want to jump too close. My body can turn and contact that vehicle. If I try to jump 5 feet, 6 feet, 8 feet, or 10 feet out here, I guarantee you're going to stumble or you're going to fall on the ground. Within 10 feet at 40,000 volts, you're dead. It'll literally set you on fire. You're dead. Okay. All I need when I jump out of that vehicle is somewhere between 2 to 2.5 feet. That's all I really need. That will get you clear of the vehicle where your body can't turn and contact it. And it'll get you clear enough and safe enough where you can land stable vertical on the ground. Okay. So somewhere between 2 to 2.5 feet. That'll put you normally somewhere about 2/3 of the way to the swing of that door on a truck like this. The door can move, can it? And the door can move unexpectedly, correct?
Yes.
That's my first threat when I'm on the ground. I've got to get clear of the door swing immediately, quickly, without separating my feet. I got to get from here to here, from point A to point B, without separating my feet, and I've got to do it quickly. How do I do it?
Jump away against. So feet
Okay.
together.
When I land like that, right?
Yeah.
So my feet are touching. Once I'm on the ground right here, my feet can never separate. That's what'll keep you alive. Your feet can never separate. I can hop like a bunny rabbit if you're very good at hop like a bunny rabbit. I don't suggest that on uneven ground, but that's one way to do it. The other way is to quickly scoot, half step at a time, rub the leather on the boots, move the dirt. Okay. As each foot goes forward, you're always at the same voltage level, as long as they're touching. As long as you don't separate them, you'll get where you need to go. Okay. Once I'm clear of the door swing, I might want to plan my path. Stop for a second here, look around, see which way you're going to go. Do not step over obstructions that separate your feet. Scoot around any obstructions. Scooting is not going to be quick. It's the only way I know to get you where you need to go, though. As long as you never separate your feet. Okay? That is the key. Once you're on the ground, that's the key to it. Yeah. I've came across 4 accidents in 4 years on the highway in the middle of the night, where they've hit a power line. There's power lines on the vehicle. 2 of them, the people are already dead. One guy apparently had a heart attack before he even had to wreck. One guy tried to climb out the vehicle like he got into it. It set him on fire and he was melted to the truck by the time I got there. The other 2 of them, I was able to get them out of the vehicle and get them away from the vehicle like I did. I scooted backwards. They saw what I was doing. I know that works. I've used it in the real world. I know it works. I don't know about the bunny hop. People don't hop like a bunny rat normally. I don't trust the bunny hop personally. Go up and try it if you want to. Okay. But I know that although it's not as fast, I know that works. Okay. If I had to do it again tonight, I would do it again the same way tonight. Okay. I trust that to do what it needs to do. At normal line voltage in the oil field out here, we have 12,470, 14,4 on the power line. One phase of ground is right at 7,200 volts. That's the most common situation. Okay. At 7,200 volts, I need 35 to 40 feet from tires and outriggers in dry conditions to be clear of the gradients in the ground we're talking about here. Okay. That gets me clear of the step potential problem. In damp conditions or wet conditions, I need 50 to 100 feet to get clear of those gradients. Okay. At 40,000 volts, I need 100 feet minimum in dry conditions. And between 100 feet and 175 feet in damp or wet conditions. How the power line is above the ground, further you need to go. Once I transfer to metal towers, no less than 100 feet at a minimum. Okay. I'm on a 60-foot, 80-foot pole, 100 feet. Okay. But we use metal towers, 100 feet minimum. Besides step potential, which is talked about right here, we've also got touch potential in the field. A lot of metal cabinets in the field that can become energized due to a fault inside the equipment. Okay. How do you make sure that metal cabinet's not energized before you put your hands on it?
A voltmeter?
Maybe, unless you buy the expensive leads on a voltmeter, they're 6 feet point to point. What comes with the meter is usually 6 feet point to point. Okay. I've got to get clean contact on the cabinet itself somewhere, bare metal, not enamel painted metal. I've got to get a ground reference somewhere within 6 feet of that contact point. Sometimes they're more than that, 6 feet away. Sometimes I can't get a good ground reference within that 6 feet distance. Okay. A bolt tick or your gloves, but make sure you're not putting your hands on a metal cabinet so you know it's not energized. Okay. This is touch potential. A while ago, we talked about step potential. Somebody wants to bring in here. Would you like to take a break? Right at about 9 o'clock, we should take a break. I'll bring a timer up on the screen and give you a 10-minute break here, okay? Get off of that. Yeah, there we go. Enjoy your break. Yeah. Yes, sir. This is Dan Dozer trying to call.
Hello?
It is translated in Spanish. Yes, sir. I use Zoom, and Zoom does live translations as I'm talking. So it is live translated in Spanish, which is also why I use Zoom. No, sir. It's online. Yes, sir. Yeah, it's too hard to translate one in a live class. I've tried that several times. The class takes 12 hours versus 6 or 7 doing it that way. Yeah. Yeah, that channel will be updated here in about a week to everything for 2026. I'm actually doing a refresher class today this morning. Yeah.
Can you call me? 432-6643.
Okay. I'll let anybody log into my class while I'm doing training. I'll freely let you log in and out and see what we're doing, what we're doing. If you want to look at it.
And
Okay. If you want to do that, let me know. I'll give you the login information.
I can see them.
Yes, sir. You have a good day.
I was wondering, maybe you could help me. Can't turn my camera on, but it won't come on.
Yes.
Well, so much for that break, huh? You ever notice they're never long enough? I'm gonna show you a little small light flash event here. In my world, this is what I will call a baby arc flash. Okay. When you're working on the equipment, you're facing the equipment and you're standing right in front of it, right at 18 inches away. So you're standing right here, 18 inches from the equipment to your body. What I've got here is a bar welded across all three phases. It's an intentional face-to-face short, or what they call a voltage fault. Okay. That will cause the breaker or fuse on that circuit to open up the circuit as fast as that device can operate. Okay. It can't operate any faster than this right here. Okay. What we normally have, though, is not a face-to-face fault situation, but a face-to-ground situation. That's the most common fault condition. Okay. That relies on the resistance going back to the source feeding it as far as how fast that breaker fuse is going to open. I've got a high resistance path back to the source. It may never open up until it burns the equipment up. Okay. So on a phase to ground fault, which is the most common fault, the resistance back to the source is going to determine how fast that breaker operates. Okay. So you're standing right in front of what we're going to call the best case scenario here. Okay. Right here. And this happens.
Okay, ready?
Thereby.
Cameras ready?
Roll.
Here we go.
Wasn't too bad, was it? You able to see that? Wasn't too bad, right? Let me show you what's going on in that little situation here. Most of these, number one, are done and over in 2 seconds or less. Get back to right where this one starts. Right there, 16.80 is where the event starts. Okay. Right here is what they call the plasma. That's what 35,000 degrees comes at you. Okay. You're standing right in the middle of that. What do you think is going to happen? What do you think you're going to do that you can't control when that occurs? If you're in a really dark room and didn't know I was in the room, and you walk by me and I reach out and grab you, what would you do?
Jump.
Jump and most likely
Yeah.
take a breath of air. People go, and they get surprised. When you do that right here, guess what you just did? You sucked all of that fire, flames, chemicals, and all that boiling metal right down your throat, into your lungs and into your stomach. Okay. And you burned everything in the process. Okay. Your life's done. You may not be dead, but your life's done. Okay. You don't want to suck that down your throat. I'll tell you several ways in the hands-on to avoid that. Okay. Little better picture of all that plasma coming out of that blast. Okay. The orange area down below the bottom of the screen here is molten metal. Off that bar we welded across all three pads, that's molten metal being blown out under pressure, usually around 2,000 psi. Okay. Here's the bus burning. The bar is actually getting involved now, burning behind it. Okay. Then you see all the shrapnel coming out. That's bits and pieces of metal. All those white specks is metal fragments. By the way, we started at 6.80, we're at 7.6. Not even 1 second into this event right now. So we're right around 8.25 or so, right around here. It's where the breaker opens up the circuit right there. Nothing else is feeding the energy. Okay. So 6.80 to 8.26 is not even 2 seconds. It is done and over in less than 2 seconds. How fast can you move?
Not fast enough.
No, sir. By the time your mind registers the when it starts, by the time your mind registers that, it's done. The damage is already done to you and anything else. It's already done. Okay. You cannot get out of the way quick enough. If you knew it was coming at 7.60, you couldn't move in time to get out of the way. It is that quick. The best way to avoid this happening is what? Do you know?
Take it aside.
Turn it off. Shut the power down to it. That's the best way to do it. Okay. In fact, OSHA says you will, says you shall shut down the power anytime you're doing a service maintenance repair of the equipment, except for 2 conditions. Shutting the power down makes it more dangerous, or it's not feasible to shut the power down. Okay. It's more dangerous shutting the power down. I don't want to do that. Okay. The not feasible part, though, is what gets people. It's kind of a gray area. They don't understand what not feasible means. Okay. If I've got to walk 300 feet to a disconnect on a pole in the field to turn the power off, it's inconvenient, but it's not feasible. I can do it. I got to go up 5 flights of stairs, find a breaker in the panel for the circuit I'm working on 5 flights below. It's inconvenient to walk up 5 flights of stairs and find it, but it's not infeasible. I can do it. Okay. Not feasible means you can't accomplish the job you're there to do with the power turned off. That doesn't mean it's on the entire time, though. Okay. When I'm troubleshooting the equipment, when I'm trying to find a problem to solve a problem with the equipment, sometimes I've got to see voltage and current readings, don't I? Sometimes I need to see operation of equipment, relay operation, or something else. I can't see those things with the power turned off. It's got to be on to see those. When I'm troubleshooting that away, I turn the power on when I need to see something. When I'm done seeing what I need to see, I turn it back off. I verify the switch before I start, make sure it's working. I turn it on and off as I need to see things. It is off 80% of the time. That means less chance of me dropping a tool accidentally or something else causing a problem. Okay. You could actually drop a tool out of your hand and blow it up and kill yourself for accidentally dropping a tool. That doesn't make sense to me. Okay. So keep the power off when you don't need it on. Only have it on for a specific reason and only for a short period of time. Just see what you need to see. Whole lot less chance of something going wrong. Show you a video that you can't find online anywhere. Okay. I got this video the morning after it occurred anonymously by email. And when I know it was anonymous, the guy said, "Hey, Dan, don't tell nobody this is anonymous." Okay. Just for information, no other reason than that. If you really want to send something somewhere anonymously, remember this website, spoofer.com. In case you ever need to do that. Okay. That removes your header information and they can't recover it. Okay. So just in case you needed to ever do that. Right here is the man getting ready to do the switching in this video. Okay. You almost match the structure around. It's hard to see him for the structure. Okay. As it turned out, I found out a year after the event occurred who it was. I know the guy 20 years when he's doing this. Okay. The guy I knew would never wear the gear. That he would argue with me in class. He'd tell me point blank, I'll put it on for you so you can check me up on it. I know how to put it on and wear it, but I'm not going to use it in the field. That's what he'd tell me to my face. I can't control what you do in the field. You wear it or not, that's up to you. Take chances with your own life, that's up to you. Okay. But he would never wear it in the field until this time. Okay. Why do you think he's wearing the gear right now? Because normally for 20 years he wouldn't. Why is he wearing it today?
OSHA.
Yeah, no, somebody's there watching. Got a lot of high-level managers to watch what's going on. He's powering up this transformer you can't hardly see back here, that huge transformer. He's powering it up for the very first time. He's energizing the bus feeding that transformer for the very first time. They're commissioning his substation. He's bringing that transformer online. Okay, that's what he's going to do. He's going to pick that handle up right here, close these switches up here, and energize that transformer. Okay. The very first time. Got a lot of high-level managers watching this thing. He spent $6 million on the project. They want to see the money. They want to watch it come online. Because they're there, he made a U-turn, went on location, make sure everything was, according to safety, hunky-dory. That's exactly the words he used when I asked him why he went there. So I need to make sure everything was hunky-dory. I guess that means everything's going the way it should. Okay. You saw that man not wearing the gear, ready to go over to the control house, put the gear on, and come back. That's where you see him right now. Okay. Safety's taking the video. Why do you think he's taking a video of this? No, you don't get a video of these things. Why do you think the safety guy is videoing him switching that equipment wearing the gear? Because I asked him that question also. He said, this guy gives him such a hard time wearing PPE. Next time he gives him, probably going to show him the video of him wearing the PPE and doing it just fine. You say you did it the other day, you're going to do it today. He's going to use the video against him next time he refuses to wear the gear. Okay. On my job, you refuse to wear the gear, I fired you for it. I don't know why they can't fire him. I just fired him a long time ago. You know. But either way, he's wearing the gear right now. Okay. I want you to watch what he does. Because they made him put the gear on this day, you got extremely lucky. I don't think that was a plan, do you? To blow things up? I can't tell you where that was, but it wasn't too far from where we live. Yeah. I said, don't think that was the plan. We'll try to get it up here and see if I can show you the very last picture of him. That's where it starts initiating right there. When I got the video, I took the video and played it, so what was going on. I put it in Adobe Premiere and took it apart one frame at a time, okay? The video was recorded at 30 frames per second. What that means is for every 1 second, I've got 30 individual pictures. That means every picture, every frame represents 1/30th of a second. That's one frame. Okay. All 3 phases right here are involved at 1/30th of a second. They're involved in the exact same frame. Okay. The only way that can happen that quickly is a dead short across all 3 phases somewhere. It can't happen that quickly any other way. It is impossible to happen that quick any other way. Normally, if I don't have a short, I see 1 phase involved. Time will go by, I see another phase get involved. It escalates to the second phase. More time will go by, more pictures will go by. Maybe all 3 phases will be involved. But normally you don't see all 3 unless there's a short somewhere. Okay? I've had 20 people in class since I got this that were there apparently on location that day. When I bring the video up, they say I was there. I say, before I say anything from where you were, what did you see? Can you describe the scene you were seeing to me? All of them but one, where they could see the backside of the transformer, they all said I got yellow one-aught ground wires hanging everywhere off the bus. What would that tell you? Think they might have still been grounded out? And no one bothered to check that, apparently.
Yeah.
This guy right here, it's his job to know it is safe to power it up before he powers the switch up. That's his responsibility. You turn the switch off or on, either one, that's your responsibility. Make sure it's safe to power it down or power it up. Okay? He's supposed to walk around the bus structure and the transformer, make sure everything's ready to go. Okay? When I found out who he was, I've known the guy for a long time. I said, hey, did you walk around the transformer? No. Why not? It's your job. Well, didn't need to. Why didn't you need to? Said 2 people told him it was ready to go. Don't trust other idiots. Okay? Dead serious. I don't care how smart the person is. They're telling you it's ready to go. Don't trust them. They're an idiot telling you that.
They make mistakes.
You verify it yourself. If your hand's on the switch, you verify it yourself. That's your responsibility, legally and otherwise. Okay? Don't trust other people. He trusted them. It almost killed him that day. If he hadn't been willing to get, it would have killed him. Okay? Don't trust them. You see this blue light up here?
Yep.
The only thing that makes that color on the structure is electrical energy. That iridescent blue you see radiating there is from electrical energy on a light flash. Nothing else makes that color light on the structure. Yeah. That will come out right before the blast. If you get lucky at all, you might see that blue indication right before it goes boom. Yeah. That's where it starts. You see it starting down here also. That's unique to electrical energy. If I can get you to the very last picture, you can see him here. You back up a little bit. Yes, before that. Try to get it. There it is. That is the last image of him as he gets knocked down to the ground and beat up a little bit on the gravel. He got lucky. Didn't get any burning. Got bruised up and stuff hitting the gravel, but that's about it. When I found out it was him, I saw him a year later. I said, hey, let's go to lunch. I ain't seen you in a while. I'll buy you lunch. In his truck in the passenger seat is a 40-calorie suit. He would never wear one before at all. He would argue with you and refuse, flat refuse. Okay. I said, hey, what's that? He said, that's my buddy. The people he works with now told me several times when he gets out of the substation, the switchyard, the MCC building, it's like he's wearing the gear while he's driving the truck. He wears it now, even when he doesn't necessarily need to wear it. Why? For 25 years, he'd never wear that 40-calorie suit. mean, he'll flat argue with you and tell you, I'm not going to put it on and not wear it. And got away with it. Why does he wear it now? Even no one tells him to wear it.
Saved his
Doesn't mean
life.
it necessarily. Why does he wear it now?
Saved his life.
Yeah. It got real to him. At that lunch, when I bought him lunch that day, said, you know, Dan, that crap you showed in those classes, man, that shit does happen, doesn't it? That was his comment to me. I said, yeah, it happens more than you think it does. 2,000 times a day nationwide. Over 2,000 times a day. Someone gets hurt in an arc flash. Yeah, it happens when you least expect it. That could have been avoided. He could have walked on the transformer, saw those one-eyed ground wires hanging everywhere on the other side of the transformer, stopped what he was doing, made him clear the grounding phase on it, and then powered it up after that. All he had to do is walk around the transformer. He got lucky that day. Very lucky that day. This is a 15-year journeyman lineman. Okay. He's got a routine job today. The power line, closest power line to the road up here. Let me get my pen back here. Come here, pen. The roadside phase, as they call it, the closest line to the road. The power wire holding it down to the insulator is broken on the line. He's going to go up to the bucket, take the old tie wire off the power line, put it back in the saddle of the pin, the insulator, and tie it back down. Okay. For a 15-year lineman, he could do that in his sleep. It would be that routine a task. Okay. Normally, you park your truck, your bucket, on the side of the part you're going to work on. That's conventionally the way you do it. That way you're not in harm's way for other things. He didn't do that day. He parked that rig over here on the opposite side of what he's going to work on. That causes a problem for him. Now he's got to cross underneath the other two phases. See where he's at? And he's perpendicular to him on top of that, which is never a good place to be. Okay. They think he went to raise the bucket a little bit. When he did that, he raised up this old hoist. See this hoist right here? That's conductive. That's a metal pipe. It's conductive. If you get that across two phases, guess what's going to happen? It's going to short them out. Okay. That's why the knuckle of the bucket right here is on fire. You cut the hydraulics on the knuckle of the bucket right here. And eventually, it catches him on fire. That's him hanging out of the bucket on fire. Okay. You see the orange cover, the orange hose right there? See all that? Who do you think put that on the line?
He did.
He did. I don't need it if I pull the fuses, do I? He didn't pull the fuses on all three phases. He left them all energized. He's working that energized for no reason. There's no reason to work it energized. Okay. If you're the one doing the work, at the point where you're the one doing the work, you are considered to be, by law, the qualified person. If something goes wrong, it may be a question in court later on whether you're truly qualified or not. But at the point in time when you're doing the work, you are by default, by law, the qualified person. Where you locate your equipment, how you use your equipment, the task steps you do, the sequence you do them in, the tools you use, is your call. It is no one else's call if you're the one doing the work. Don't give your authority to someone else, number one. Okay. Number two, he could have shut it down. No one could tell him he can't. He's supposed to know what it affects. He's supposed to make sure it's safe to shut it down before he does. But he pulled all three fuses and de-energized that line. He did not have to work it energized. He chose to work it energized. That was his choice. Who lost right here? It's based on your belief systems over with, aren't they?
Yeah.
Who lost in this case, really and truly?
He lost.
He's dead. What
Very
about them?
lost.
Not only did they lose husband, uncle, brother, cousin, father, whoever he is to them, they've also lost over half their income immediately. The male in the family typically brings in 60 to 70% of the family's income, if not more than that, because he can work overtime and everything else. Okay. They've just lost over half their income immediately. You think they can maintain a house payment, a car payment, utilities, and food for the family on less than half the income?
So,
Nope. That's immediate because it was his fault. They don't get any insurance. If they're real lucky, someone will take up a job site collection at the company, maybe for the family, they may get a couple $1,000s. That's how many people are there, how generous they are, what they can afford to give. They may get a couple $1,000s out of that. That's it. And in about 100 days, right in the middle of the grief cycle, actually, in about 100 days, they realize the house is being foreclosed on, the cars are being foreclosed on, they're repossessing cars and everything else. Right in the middle of the worst part of the grief cycle, they're going to get hit with all of that. All because he can't pull the fuses or park the vehicle where it needs to be parked. He could have done either one, it wouldn't have happened. He set it up from get-go where he located the truck. They lost. He's dead, but they lost. I've been known in the last few years I worked in a bucket. I did this. I blocked the entire road. I actually started doing that intentionally. The last 5 years I was in a bucket, I blocked the entire road intentionally. You know why I would do that? Cars keep hitting my damn outriggers. I'm serious. They can't clear that truck and the cones and everything and not hit the outriggers. I got tired of it. I blocked the entire damn road on them. If you're getting home, going to work, etc., that's not my problem. My problem is not getting killed trying to do what I'm trying to do on the damn power line here. Yeah.
Right.
People are that stupid on the road. Yeah. I've had them so mad at me, they called the city police, sheriff's office, and one time called the marshal service on me. If enough people call, they will respond. What do you think they tell when they get there? I've had 3 agencies respond one time. What do you think they tell me when they arrive? If I'm in the air, they don't say a word to me. If I'm not on the cradle or on the ground, they don't say a word to me. What they do is they'll put a car over here and they put a car there, block traffic going that way, block traffic going that way, keep people away from me. That's the first thing they do is secure the area. Okay. If I come down and cradle up or something like that, then they come say, hey, dude, you stay around a little bit longer. What can we do to help you? I've been asked one time and one time only to give them one lane. They said they got a fire truck 4 miles out coming that way. Can't go where you need to go any other direction but this road. Say, can you give us one lane? I said, I'll give you the whole road. You know, I rigged down real quick and got off the road, got out of the way. You know, but they asked me to give them a lane. They didn't tell me to move the truck. Okay. I've never been told to clear the road when I was doing work. Okay. I've had probably 10 people over the years hit my damn outriggers on my truck. Yeah. You know how badly that shakes you in a bucket?
thought your bucket
I knocked out a bucket a couple times hitting it so hard.
I don't think he's working, really.
You know, you'd think they could see that big white truck and the lights everywhere in the cone, wouldn't you?
Yeah, he went to.
But they don't.
And went to.
Do you think this guy might have got a little complacent doing what he's doing?
What the extra?
You think that might have played into it a little bit?
Yep.
I've never been in a class where they define complacency to me. So I'm going to do that for you so that you can actually see what complacency really and truly is. Okay. Your mental state smug today, your sense of comfort and unshine security. You don't think that's going to happen. You're overconfident. You think you got everything under control. You lack awareness for potential problems and dangers. And you have reduced vigilance for things. Yeah. That is what they mean by being complacent. So I've never had a safety class define that to me. That's why I wanted to bring it up for you. Everyone gets complacent sometimes with certain things. The more you're around something, the more you interact with something, the more comfortable you become. At a certain point, that becomes confidence. Confidence leads right into complacency. Okay? So everyone becomes complacent with certain things. I had a guy pass me about 4 months ago going down I-20 in the 80-mile-an-hour zone with that trailer behind my truck. And I'm trucking along at 80 miles an hour. Okay. I weigh 16,500 pounds going down the highway between my truck and the trailer I pull. Okay. You say he passed me at 80 miles an hour, looked over at me and looked like he was in an easy chair, driving that truck and trailer down the highway. I thought, if that's his impression, passing me at 80 miles an hour on that highway, I may be getting a little bit too complacent with what I'm doing here. Getting a little too comfortable pulling that trailer down the road. Reminding myself, no one's that good. Don't let that come up too much. But it happens to everybody. If you catch your clothes on fire while you're doing electrical work, most likely cause is an arc flash or explosion. Okay? If that's the case, stop, drop, and roll we talked about a bit earlier will not work for you because you won't be able to think about it. It will not be a thought in your head. I promise you, you won't be there. I'm going to show you a video to illustrate that point. Okay. The pink and yellow jacket is an FR rated jacket. The tan jacket, the standard Carhartt jacket. Tell me in a minute if the guy wearing the tan jacket would even be thinking about stop, drop, and roll. Okay. Hold yours just a little bit. It's kind of loud starting out. Stop him there. What do you think he's thinking about?
He ain't got time to think about nothing.
No, them thoughts come later. Maybe. Right now, two things are happening immediately. Flames taking all the oxygen out of the atmosphere. He cannot breathe. It's all going through the flames. That's what's staying in the flames. Okay? The second thing is, how high do you think the pain is around his head? He's on fire. His head's being burned with flames. Now, how do you think that pain level is going to be?
Pretty high.
Extremely high. Okay. He's not thinking about anything else. The brain's registering extreme pain and suffocation. Nothing else is getting through past that right now. Okay. That puts him what they call primal instinct. Well, primal instincts are fight or flight. Okay. He is down to the reptilian brain level, fight or flight. What do you think he's going to do?
Run.
If at all possible, he will run. But before he does that, here's what he's going to do. You'll turn around 3 to 5 times and then take off running, if possible. I've now got 19 videos where guys in an enclosed area, a small room or something here, where this occurs. 18 of the 19 videos, they turn around 3 to 5 times and start running. One video, the guy got knocked out when it hit him. He couldn't turn around and run. 4 of them, they run right back into the equipment, blew up on at full speed, right into the equipment. They're blind. The flash is so bright, they're blind for hours, maybe a day or so. Okay? They can't see where they're going. It is so loud, it's like a 45 automatic going up in your ear. You hear muffled sounds, you can't differentiate tones and voices. So he's blind and he's deaf. And now when he turns around 3 to 5 times, he's completely disoriented. He's deaf, dumb, blind, and disoriented. Which way is he going to run?
When he stops.
Whichever way he's forward when he stops turning around. Okay. That's why 4 of them run right back into the equipment. The same equipment blew up on them, they're running right back into it. Okay. For a human being, this is the worst case scenario. It's a funnel fire situation and all your vital organs are involved in it. All your vital organs in your chest and your head and your brain. All of them are involved in it. When you work on equipment in the field, what's exposed is this part right here, from your waist to right above your head, and you're facing the equipment 18 inches away. That's why this is so deadly. Okay. If there's a drop off 10 feet away from him right there, you don't know it's there. Don't remember it's, not thinking about it. You run straight off of it at full speed. Okay. That's how dangerous that situation is. I could have soft dirt right in front of me. right here. And all I got to do is fall down and roll around, and I'll run the other direction. Because the brain is not engaged for at least several minutes. Stop, drop, and roll is not going to work for you here. So for most of us in electrical work, stop, drop, roll would do you no good. Because you're not going to catch your clothes on fire usually any other way. How close are you to 36? Are you like I am, quite a ways past that point?
A little way fast.
Here's why I'm saying 36. That seems to be the magic number here. Okay. From below your waist to right above your head is what's involved in a flash event. Okay. Right here. Around your body, that is 64% of your body mass medically. 64 and 36 equals 100. If these numbers equal 100, your chance of surviving that event is minimal. According to the books I read, 10 to 20%. According to the burn doctors I've talked to in person, 5 to 10%. Okay. When I was 50, I talked to the chief burn surgeon at UMC in Lubbock, Texas. My ex-wife was a nurse. She introduced me to him. We had a discussion about what I do. Okay. He told me, if you reach 100 at this point right here, your chance of surviving an electric flash is 5 to 10% max. At that time, he was a 35-year chief burn surgeon, the chief instructor for burn care for Texas Tech Health Sciences Center. I'd probably take his word for burn injuries, wouldn't you?
Yeah.
Think he knows what he's talking about? Okay.
Yeah.
In fact, he asked me when I was talking to him, said, by the way, how old are you? I told him, I'm exposed doing training to light equipment also. I said, I'm 50. That was 19 years ago, so I'm 50. He said, you're in the negative numbers. That's what he means. He said, your chance of surviving that event is not 5 to 10% now. It's minus 20%. He said, in every 10 years, you can add 10% to that roughly. If an event occurs, he said, even if you're protected, it's going to be worse for you. Because the chance of surviving that and having the right protection at the time it occurs is pretty slim also. He already knew that about PPE. Like I said, how close are you to 36? Because right around 36 to 40, your body metabolism slows down. It takes longer to heal. It takes longer to generate new cells. And every year you get older than that, it's less chance. Right around 40, at least you need to start being real careful what you're doing out here electrically, particularly in the other situations. In case you're not aware of it, we've always had first, second, and third degree burns. We've now got an official fourth degree burn also. That's where we go through all the skin layers and literally burns and chars the bone. Particularly on arc flash events at the back of your arm, where the skin's real thin back on the back of your arm, and your shins below your knee where the skin's real thin also. That requires skin grafts and amputations. Once it destroyed the bone structure, it's very hard to recover the bone. Okay? But because of arc flashes, now we've got an official fourth degree burn also. What voltage do you think injures or kills more people, particularly on a job site? What do you think it'd be?
480.
110.
Would you believe it's 120? Out of all the different voltages we come across, like 122, 42, 77, 480, 4160, etc. 120 is the deadliest voltage.
480 will blow you away.
It's most common too, isn't it?
Yep.
People take it for granted. They think it's no big deal. Okay. I have a friend whose daughter stayed here a few years ago when he went out of town. They moved and his daughter stayed in town. He called me one weekend and said, Dan, could you add a receptacle in the bedroom for my daughter? I said, yeah. I said, take me a week, but I'll get to her next weekend or something. When I went over there to add that receptacle for her and something, that's an easy job. Okay. She's got a little 3-year-old toddler running around. She got a metal toy fork in her hand, and she's poking everything at that metal fork, including me. Okay. I told her mom, I said, you need to cover your receptacles up. There's a little plug-in there. You can get to plug your receptacles and cover them up. She said, oh, that's not dangerous. I said, if she puts that fork in there, could electrocute her or burn her really bad? She said, oh, that can't be that dangerous. Lady's 24 years old, got a 3-year-old toddler. Okay. I said, what makes you think that's not dangerous? She said, I know this day and age, you can put something dangerous in my baby's nursery. She made a bedroom a nursery when she had the kid. Okay. I said, ma'am, you're correct. If the house was designed as that being a nursery, you're exactly correct. It's all low voltage. I have to wire those low voltage. Nothing dangerous to that child. But it wasn't designed as a nursery. It was not wired as a nursery. You made it a nursery. It was a bedroom. I said, well, it still can't be that dangerous. Okay. So I got done the job, had a receptacle for, went to my truck. Before I left, I got my generator out, took a piece of cord, put a male cord cap on one end, and stripped the other two ends out, bare wire. Took 2 pieces of 1/4-inch metal, laid them in a V on the tailgate of my truck. And I told her, I want you to watch something. With the 2 ends of that cord, I welded that metal together. I did a spot weld in the middle and welded that metal together. It turned bright red and liquefied. She said, oh, crap, that is dangerous, isn't it? I said, yes, that's what I've been trying to tell you. So I gave her a bag of covers I bought while I was at lunch. I said, here, let me show you how to put these in. Let's protect your daughter. Okay? For some reason, common sense isn't that common anymore. Okay? On the job site, even in the real world, it's just not that common anymore. Okay? You'd think a 24-year-old female to child would know that could be dangerous, wouldn't you? At least I would have thought that. But apparently, not in that case. I ran crews for 23 years in the field doing electrical work. From power line all the way down to wiring houses. Okay. I watched my young guys when I started running crews really, really close. My thought was they think they're immune to damages, think they're 10 feet tall and bulletproof. Nothing can hurt them. They're inexperienced. they don't have a lot of common sense yet here. Haven't been on construction sites very much. Don't know the flow of things. Just inexperienced and think they can't do anything. Then, as it turned out, I was watching the wrong group. This chart right here is 70 years old. It hasn't changed in 7 decades. Look at this group right here.
Oh,
My 30-year-olds. Why are they the most dangerous group? They have more fatalities, injuries, and deaths on the job than any other group. Why?
because they don't think they're gonna get hurt.
Well, how long have they been working?
At least
By
some
the time you're
secrets.
30 years old, how long have you been on the job?
Quite a while.
Usually 10 or 12 years, right? You start at 18 or so, you go or 20 or 10 to 12 years. How comfortable you think you're getting? What's a guy you hire sometime? First 6 months, he's not real sure of things. After a year, he's getting better. 2 years, he's got a handle on it, doesn't he?
Yeah.
Thinks he knows it all, doesn't he?
Yep.
Problem is, he doesn't know what he doesn't know yet. That's the problem. My 30-year-olds are the same way. They've been there 10 years, man. They got a good handle on stuff, haven't they? And the answer to the question makes sense. They actually have an idea what they're talking about now. They're overconfident. They're becoming complacent right around the age of 30 or so. Too comfortable, too confident. Okay? That's what causes all these injuries and deaths around 30 years old. Okay? Right around 40, it starts dropping off right here. That's a 14% drop from the high right there. And it hadn't changed in 70 years. Why ain't such a drop off around 40?
They realize they don't know everything.
Now, you've seen a few things, hopefully. But what's most men's lives like around 40?
More cautious. You got
Sorry?
families.
What's your life like around 40?
Got more families. You got more
Yeah.
responsibility.
Most people are
That's-
slowing down a little bit, not going to the bar 5 nights a week, you're down to 1 or 2. I got a family to take care of usually, got a house payment, a car payment, a truck payment, boat payment. You got a lot of responsibility around 40 usually, right? That's what makes the change. All those responsibilities you got around 40 years old. Okay. Who's expected to pay for all that stuff?
You are.
We are. The male. I'm being chauvinistic. It's true, though. They expect us to work and pay for it, don't they?
Yep.
Okay. If you're hurt and can't work, how do you pay for all that?
Yeah.
That reality sits in about 40. You realize you got to work. You got to go to work. You got to be there every day to earn the money to pay for everything. Right? I've had many times running crews. It was me and Theraflu. I should have bought stock in Theraflu when I was a foreman. Okay. I've had many days. My crew works paycheck to paycheck. My granddad and dad taught me not to work paycheck to paycheck. I've always got a buffer. Okay. But my crew works paycheck to paycheck, and I know that. Okay. They can't afford a day or two off work that week. They can't afford it. I've had more than once I was working sick so that they got paid, more than anything. Back to responsibilities, right? Yeah. That's responsibility also. Yeah. Somewhere around 55 to 60, right in that range between 55 and 60, it drops again from here to here. Why such a big drop around 55 to 60? What's coming up? Retirement. I've had many people tell me, I'm just trying to last retirement, man. I'm trying to make it 65. I've heard that 1,000 times. Okay. You think that guy's going to take any chances when he's getting that close?
No.
Not consciously. He knows not to take any chances now, doesn't he? You don't want to screw it up between now and retirement, does he? Okay. I'm going to tell you something. You might have heard this last time. You might not have caught it. I've seen for 48 years in the field. I've had people retire off my project. Okay. I kept up with 4 of them since they retired. Okay. I see them about every year or two, all 4 of them. Everyone I've met that quit working and didn't have a plan of something to do in retirement, they're not happy. They're irritable. Their health goes down here very quickly, and they don't last very long. Most of them don't last 10 years. A lot don't last 5 years. Okay. When they say I'm going to go fishing every day or go golfing every week or so, yeah, that'll work for about a month or so. Till you find out the cost of drugs have gone up, your health is going downhill, you got more problems than you thought you had. All of a sudden, you can't afford to go golfing every week. Green fees are expensive. Okay. You can't go fishing like you plan to go fishing and things like that. All those things there are nice to do once in a while. It's not a steady diet of it. Okay. When you find out you can't do what you plan to do, now you get grumpy. And that has to affect your outcome. Okay. You're not happy, your health's going downhill. In fact, 4 people I've kept up with that had plans something to do in retirement. One guy, before he retired, 5 years before he retired, he said, you know what? I think I want to make custom hunting knives in retirement and sell custom knives. 4 years before he retired, he found a guy in Midland, Texas to make custom knives. Paid him to teach him how to do it, how to actually make the knives, how to sell the knives, how to set the business up, all of that. The guy taught him how to do all of it, got him set up before he retired, in business selling custom knives. Okay. He's been retired, I believe, 11 years now. Guess what he does all the time? Makes custom knives and sells them. He goes to gun and knife shows around the country, county fairs, state fairs, wherever he sells knives. Okay. 2 years ago, paid cash for an $80,000 motorhome. Pay cash. Showed me his bank account last year at lunch. I said, you've had to use some of your retirement. He said, nope, not a bit, not a dime. Every deposit from the company's retirement, from Social Security, went into his account. No withdrawals in 11 years. All that's been going to his bank account. He lives off his knife sales. He makes more money on a weekend than he made gross from the company he retired from. And has been doing that for 11 years now plus. Okay. His health stays good. His mind stays sharp. He enjoys what he's doing. He meets new people all the time. He gets custom ideas for knives and designs and handles all the time. He's enjoying retirement. Okay. That's what you need to do when you retire. Honestly, when you quit doing what you're doing, find something you enjoy doing that you can do in retirement. Hopefully makes a little bit of money for you. That's always a good thing in retirement, by the way. Make at least a little bit extra money for you that you can do easily and sell. It's not that hard to do. Okay. Plan that before retirement time. Think about it before you get to retirement. Okay. I told you all earlier, I'll be 70 in January. On January 4th, I'll be 70. If I plan to retire at 65, I screwed that up, didn't I? I just ran right on by it, didn't I? Okay. Last month I had to file for my Social Security. You got to take that mandatorily at 70, no matter what. Here's where it's going to go. Straight to my bank account. I don't need it right now. Hopefully I won't need it for a while. Okay. So while I don't need it, I'm going to bank it. Okay. You're looking at my retirement plan. You're seeing exactly what I plan to do in retirement, what I'm doing in retirement, so to speak. Okay. I'm going to keep doing what I'm doing right here. So I can't do it for one reason or another until you want to shoot me over it. If you want to shoot me, it's time to quit. Okay. But other than that, this is my plan. Okay. Find something you can do and enjoy doing that you can do in retirement. Plan it before you quit. Okay. Everyone I've met that did that are happy in retirement. They're enjoying their retirement, and it's going well for them. Everyone I met that didn't do that, it's not going well. Particularly now, prices going up and everything, it's not going well for them. Okay, so just a suggestion from an old man. Okay. We've had 3 changes in PP requirements in the past 7 and 8 years here. First change is anytime your head is inside an arc flash boundary, you've now got to wear the balaclava. Okay. Even now, category 1 used to be exempt. Okay. My head protection in an arc flash boundary now is NC-Z87 plus safety glasses, the sock of the balaclava, and hard hat and a shield at a minimum. That's my head protection. Okay. And the safety glasses are required behind the shield. The shield rate is based on safety glasses. In case no one's ever told you that part about the shield. So you have to have safety glasses behind the shield for the shield rating to be there. The second change was supposed to happen before COVID. They're going to change the letters HRC to PPE on all of our labels. That has not happened due to COVID. I keep hearing it's going to happen this year sometime. I'm not seeing labels PP on them other than HRC. Now I'm told somewhere next year you'll start seeing new clothing with PP instead of HRC on it. Yeah. Most labels say like HRC2, meaning category 2. All they're going to do is change HRC to PPE. It'll be PP2 instead of HRC2. That's the only change they're talking about. There's nothing other than the letter change. Okay. The third change is anytime I'm wearing steel-toed boots, you wear steel toes for crush injury, they've got to be EH-rated boots. Okay. The ones I wear normally are Red Wings. They're 14,000 volts for 3 minutes. If you don't know if your boots are EH-rated or not, you can take the tongue and turn the tongue label out where you can read it. At the bottom of the label, it'll usually say EH if they're EH-rated, electrical hazard rated. Got to be on the inside of the tongue label. I don't wear steel-toe boots. I refuse to wear steel-toe boots in the field of electrical work. I wear composite toe. So that's my call. We'll take the last break. Got one last break. Bring our timer back up on the screen here so you know where we stand on it. Take 10. Yeah, so much for that last break. Looks like I've got a few people still on a break here. Give them a minute or so to get back. Thanks, Ronnie. Hey, Ronnie, do me a favor. Put your license number in the chat for me, will you?
Okay. Do you
That
need
way-
driver's license or master's license?
You ask for your electric license.
Okay, I'll
That
do
way
it.
I'm turning the credit for you today.
I'll do it right now.
Okay, thank you.
Hey, I got your address. Are you on Lemonwood?
Yes, sir.
I'll send you a check today. How much is it?
Ronnie, you don't have to pay me for it.
Thank you, sir.
Just give me your license and I turn the credit in for you.
God bless you.
Looks like everybody made it back. Good deal. Daryl, are you back? Thanks, sir. Thank you. Appreciate it. We're going to wrap up here a little bit. When you're using the PPE, whether it's your shirt, jeans, gloves, whatever it may be, you need to take a minute and inspect them, make sure they're ready to go. Yeah. I'm going to walk through the glove inspection right quick with you here. If you can. I'm looking for anything that makes that rubber not as thick as it should be, that decreases the thickness of it. Any damage to it of any kind, like holes in it, deep cuts, cracks in the rubber, things like this, any kind of blister, swells, hard spots, weak spots in the rubber. Particularly if I see an interior color like I'm showing right here through the exterior color, don't want to use the glove. Okay. I want to see the same thickness for rubber, same pliability or flexibility throughout the entire glove from fingertip to cuff. Okay. This is what they call a glove pump. Lets you do a real good inspection on gloves. Okay. You can overinflate them. It won't hurt them. They'll pop off before it hurts them. Let you overinflate it and you check it over really, really good that way. Okay. You need to do an air test on the glove as well for damage. Trap air in the glove. One thing we'll do in the trailer is a manual glove test. Okay. Roll it up really, really tight when you get down to the wrist right here. Hold those corners in so it can't leak out the cuff. You get right here, bend it back across your fist, put pressure on it. Okay. The first task I'll have you do, other than sign the roster for hands-on, will be to do a glove inspection. Okay. We'll do a manual glove inspection. That's our first task. Okay. All this feeling airflow, letting the air leak, and pin on the glove. If I'm in a classroom with the air conditioning turned off and no noise in the classroom, I might hear to feel it. Out in the real world, with any airflow at all, any kind of ambient noise, you're not going to hear it or feel it out there most likely. But you can tell if it deflates on you. So that's what we'll do. We'll do a manual air test on the gloves. They are all pre-shaped to a hand. Most of them will stand up on the cup like I'm doing right here. Okay. I don't want to put anything on top of them to compress them down. They'll crack out on you. I don't want to fold them over and put them away in a bag somewhere. I don't want to turn them inside out and put them away. I want to put them away in a canvas bag that fits the glove fully unfolded. Okay. They should be in a protective canvas bag somewhere or protected somewhere from any other damage. Okay. When I put them in a canvas bag, I put them in the bag cuffed down for a reason. Keeps debris from getting into the glove, and sometimes most critters from getting in gloves. I found snakes in my glove before. I found spiders in my glove many times. Okay. So put them in cuffed down. It kind of discourages debris in animals. Okay. The rubber glove cuff, the end of the rubber glove, has to always extend beyond the edge of the leather glove cuff. Okay. That's actually specified. The distance is actually specified in F496. That's just standard right here. Okay. For 000 and 0 class gloves, I need a 1/2 inch minimum. For class 1, 2, 3, and 4, 1 inch for each class. So class 4 needs 4 inches. Okay. Class 2 gloves, which you're showing in the example right here, are rated 17,000 volts. 17,000 volts can jump an inch and a half from the conductive leather glove to your arm. That's why they want 2 inches of clearance. At no time can the rubber glove equal the leather glove cup or be inside the leather glove cup. That makes it very dangerous using your gloves. So that's always extend beyond that point. A couple of do's and don'ts here right quick. Follow company work procedures, take up procedures, what you're doing, and follow the safety rules. Okay. When you sign the rules or you sign with the company, you had to sign for a bunch of safety rules, did you not? Did you read them all before you signed for them, honestly?
Most stuff, no.
For 23 years, I gave that form out a lot of times to people I signed on my project. I know 2 people that read them in 23 years, only 2. They had a lot of questions about things. They had a lot of questions on terminology on the rules, and they were pissed off when they got done reading them. If reading those safety rules and the penalty particularly doesn't piss you off, there's something wrong. You know what the penalty is for not following the rules? Can anyone tell me the penalty?
Injury?
It's only one. They've only got one penalty anymore.
Yes.
Well, that's the end of it. The term they use is a legal term, okay? It is, quote, up to and including termination.
Oh,
Everybody forgets the up to and including. In a court, that makes a big difference. That's why they use it that way. What that means is, whatever they want to do to you, they can do. And you agreed to it when you signed the form. So you can't challenge it. If they want to move you across the country tomorrow morning at 6 o'clock in the morning, they say your job's in California at 6 o'clock tomorrow morning. Get there, boy. That's it. You can't object to it. They can fire you for not going. They can take half your pay for months if they want to. They can demote you, take your seniority away from you. They can take part of your retirement away. They can do whatever they want to do for not following that rule or those rules. And you agreed to it by signing the form. That ought to piss you off. So I don't work for other people. I work for me. I ain't going to treat me that bad. Okay? Read the rules sometime. Tell me that's not true. All of them the past 20 years have been up to and including termination. They don't say anywhere in the rules, if you don't follow this rule, it's a $25 fine or 3 days off without pay. Nowhere does it specify that on any one rule, does it?
No.
It's up to and including termination. Whatever they can think of to do to you, then you can't object to it. You can't sue over it. You can't object to it. Okay? When you sign that form, you know what your signature says otherwise? It says, number one, you read every rule you did or did not read. You can't say, but Your Honor, I didn't read that rule. It said, don't care, you shouldn't sign the form. That's what he'll tell you from the bench in the court. You shouldn't sign the form. But Your Honor, I don't understand that terminology. You should have asked. You should not have signed the form until you understood what you were signing. That's what he'll tell you. But Your Honor, it wasn't paid time. It was a party. It was company time. Anytime you're on company time, paid or otherwise, those rules take effect. It says you read all the rules, you understood all the rules you did not read, you get to follow all those rules on company time, paid or otherwise, and you get permission to use that penalty. That's what is going on there. And most safety classes won't tell you that, will they? But you ought to know what you signed. Sometime, if you never read all of them, get a copy of what you signed and sit down sometime to get you a beer or a drink or something, sit down and read what you agreed to in self-defense. Okay? Because I promise you, anymore, the company's not your friend. You screw up, they'll bring that out on you in a heartbeat. Okay? A few things not to do here. Don't wear your jewelry in your gloves. Okay? Anything conductive on person, in my pockets or otherwise, coins in my pocket, cell phone on my hip, ring, watch, whatever may be conductive in my body, is not there when I'm doing live work. If I'm doing anything energized, nothing conductive is anywhere on my body. Or a completely different belt, my coins stay in my truck, my cell phone stays in my truck, My keys stay in my truck. My ring of my watch stays in my truck. I have nothing conductive on my person. Okay. If you get petroleum products on your rubber gloves, don't waste your time trying to clean them. Okay, I've tried that for 15 years. If the stain doesn't come out of the rubber glove, I cannot trust that glove anymore. They are type 1 natural rubber. The gloves we use out in the field, the ones that we use out in the field is not Lyman or type 1 natural rubber. Natural rubber gloves can develop defects on a shelf with no one touching them, all by themselves. Okay. Petroleum products affect natural rubber gloves severely sometimes. So if you get petroleum products on the rubber gloves themselves, dispose of them. Okay. Do you know how you dispose of PPE? You know how to do it. If I want to throw those gloves away, I've got to, quote, render that PPE non-functional for its intended use. What that means is this. I cut the fingers off of them and I split them palm to cuff before I throw them away. I destroy them before I throw them away. If I don't do that, someone picks them up out of the dump and uses them, gets injured using them, I can go to prison for it. If you dispose of PPE yourself, make sure it can't be used, or it's very clearly damaged. Okay. You've been through like that tag out, I know, at least in my class previously. Who are tags for? They all want you to put a tag with your lock, right? And they want your name on it, your company name on it, contact number for you, and it's got room for what's going on. They all want a tag with your lock. Who's the tag really for? You. I don't need it. I know a lock means leave it alone. I'm going to leave it alone. I don't need a tag on a lock to leave it alone.
Somebody else don't turn it on.
That's the problem. You and I ought to know that lock means leave it alone, right?
Yeah.
All these people in the field that don't know the lock means leave it alone. These people right here, they need a tag telling them leave it alone. If you're in the field, out in the oil field particularly, and you don't understand that a lock on a switch turned off and locked out means leave it alone, you're an idiot. And you got no business out here in the field. Okay. We don't need tags. Tag saves us time. Telling you who put it on there, who they work for, how to contact them, what's going on. But I don't need that to leave it alone, do I?
Nope.
Neither do you. Okay. Tags are for everybody else. That's what the tags are for. Can you ever use a combination lock? Can I use a combination lock for lockout?
No.
Do you know?
I don't know.
Companies say no, and they can do that at a company level. Okay. However, the only scan I'll show you out of 70E directly is right here. And the OSHA regulations mirror this exactly. You read that?
Yeah.
It says either keyed or combination. Legally, by federal law, OSHA regulation and 70E, I could use a combination lock, provided, number 7, I don't share the combination. Most companies I work for and most companies out in the field, they know combination locks. They don't allow combination locks. And that's legal at their point. I could tell you for my company, I refuse to use square D equipment. You can't use square D equipment. And that's legal for my company. Okay. I can outlaw square D or Siemens or whoever I want to as far as my company requirements are. Okay. But this is the federal actual requirement for it is allowed under these conditions. Let's talk about the equipment stuff right quick before we start getting ready to wrap up here today. Have you seen these fuses before? These are low peak unlimited fuses. You seen these in the field before?
No.
They're normally used on motor circuits. If it's dual element time delay fuses, they're normally used on motor circuits, one kind or another. These are fast blow fuses. Common term, fast blow. Okay. when I've got a fault condition in the cabinet on equipment, I've got a time current curve. Okay. Get my curves. Time going one way, current going the other way. Okay. And the curve on the fault. And these fuses trip out real quickly, limiting the time buildup on the circuit on the fault. Regular fuses take a long time to blow, but let the current build up like this on the fault condition before they blow. Time and current. Okay. This is what you want to see in your cabinet. You're still going to get a blast, but nowhere near as big as regular fuses will be. Okay. Think of a M80 firecracker, a little bit better than a black cat firecracker, and dynamite. That's the dynamite. That's the M80 firecracker. Okay. Change one fuse, only one, to a regular fuse. You're looking at dynamite. Okay. I've been told for years that pumpers don't change fuses. I got one comment to that bullshit. Okay. I look in the back of their truck. They've got a box of new fuses, a bucket of blown fuses. They don't change fuses. Why are they there? Okay. They're not in training. They don't know why these fuses are in that cabinet. What's a pumper's job? What's his job? It's in his title. Pump. How does he make it pump?
Make sure the power's going.
He makes it run. He's going to change that fuse or whatever he's got available to him. He's not trained on why that fuse is there or what it does. If you got a 60 amp fuse and it blows a 60 amp fuse, you put a 60 amp fuse back in place. And all of a sudden you're behind a closed door you can't see through. It blows up and you wonder why it blew up so big. Okay. They do change fuses. I don't care what it says on paper. Okay. And they're not trained on what they're doing. So be careful in the field out here. We're going to use this particular cabinet in my trailer for hands-on training. Okay. I've got an HOA switch right here on the side of the cabinet. That's a little bit better head-on view of that HOA switch. Okay. Before you turn the main switch off on the equipment, if I got an HOA switch involved in it, always shed the load. Take the HOA switch to off mode. Okay. Then go back around and turn the main switch off after you shed the load on it. Okay. Now I got to go back to the HOA switch over here. After I turn the main switch off, I'm going to put it in every position. Go to auto, I'm going to flip over to hand, return it back to off. Make sure nothing re-engages on me. Okay. It's a contact that re-engages on me in the cabinet here. One of two things is going on. Either all three blades didn't open completely up, or I've got power coming from somewhere else into the cabinet. Okay. One of two things is going on there. And I need to know that before I get my hands in there. If I got a start button involved, like I've got right here, go to auto, push start. Flip it over to hand, push start. That's what engages the control. Flip it to off, leave it in the off position one more time, push the start button. Okay. Well, so that's what completes the circuit and engages things. Once I've done all that, then I open doors up and see what I need to do. But turn it off to start with, turn my switch off, reset control, make sure nothing re-engages on you. What do you think of my ground rod? I take ground rod. Look at the very top of it. Notice it's not smooth, is it?
It's been cut.
I hammer it or use a ground rod driver. It's going to smooth that off on top, isn't it? Yeah, they cut it off, right, Ronnie? That was almost 14 inches long. Almost. What kind of ground do you have at 14 inches?
0.
Yeah, none. Okay. Can I cut a ground rod off? Does anybody know? Can you legally cut a ground rod off? I've found a bunch in the field out here before. Okay. There's no rule anywhere in the code that says I got to drive that ground rod right where it is. It doesn't say right there. I can move it over here. I can move it over here. I can move it over there. Here, I go to a 45-degree angle. I dig a ditch 30 inches deep. I can locate it wherever I need to, where it'll dive in the ground. The rule says as close as practical to the equipment it serves. There's no 5 feet or 10 feet or none of that crap. The code says as close as practical to what it serves. I can move it around. If I can't drive it here, hey, guess what? I can pull it out and move it over somewhere else. With that leniency, there's no reason to cut it off, is there? So why do people cut it off?
Easier.
You're lazy. Okay. I took this, me and the guy that drove that were out on location when I found that. We took that ground rod out, found how long it was. I said, look, you got another ground rod? I said, yeah. I said, I took a bottle of water, a regular sized bottle of water, and my hand and drove it 8 feet in the ground without a friggin' hammer. I said,
Just a whole.
what's wrong? You can drive that ground rod. Okay. It doesn't have to be in a certain place. You can move it around. What do you think of this fuse? I got 6 of those now. I pulled 3 out 9 years ago and 3 more out about 5 years ago. Another disconnect, different location.
Oh.
The last 3 I pulled out, went up the cabinet door and saw them. I was told a master electrician did that, put them in there. I said, how'd you know he's a master electrician? He said, well, that gold license you showed in class, he had one of those also. If you're doing stuff like that right there and you're holding a master electrician license, you're not a master electrician, you're a master piece of shit. This is going to kill someone at some point. Okay. In fact, they wouldn't tell me who he was. If they told me, I'd take his license away. I guarantee him I'll take his license away. And probably get him in the parking lot and thump him a few times. Okay. That will kill someone. Eventually, that'll kill somebody. Very, very dangerous. You know what that is? A PT or control transformer. Right? Potential transformer, control transformer. Normally, we come in on the top side of this at 480 volts. We come out on the control side, feeding controls at 120. That's most common. Okay. That means it's a 4-to-1 step down transformer, bucket transformer. What if I put the 480 volts down here accidentally? What's coming out up here? You know? Because I've had several wired in 40 years, wired backwards, mounted upside down, and terminated wrong. What's coming out the other side? At 40 is on the secondary side. Normally it's a 4-to-1 step down going this direction. It's a 1-to-4 step up going that way. What's 4 times 480?
Let's see.
So it's coming out the top side of the transformer. I've got 3 meter ratings in the field, handheld meters, 300 volts, 600 volts, and 1,000 volts. Best case is 1,000 volts. If I take that 1,000 volt rated meter, make contact on H1 and H4 right here, and 1,920 volts, what's going to happen? I'm going to blow it up in your hand. I've got a fuse in the meter, but it's not on the voltage circuit. It's on the current circuit. I take a regular meter. Let me clear the screen here. I take a regular meter. I take my circuit, break my circuit, go in series with my circuit, and read up to 10 amps with a non-clamp meter. That's where the fuse is. It's on that circuit, not on the voltage circuit. I've only got 1 fuse in the meter. 1 fuse can only protect 1 circuit. Okay. So right here at 1,920 volts, there's no fuse protection. On a control transformer, the safest place to take your first reading is always going to be on the secondary side. If incoming power is no more than 480 volts, the most I can read down here is 480 volts. That's well within my meter rating, unless I got a 300 volt rated meter. That's a no-no. Okay. That's within my meter rating otherwise. I may be well above it on the top side of it. Okay. I watched people for years. First thing you check on a control transformer is right up there with no clue what's coming in. Okay. If I got 120 down here, I probably got close to 480 on the top side. If I got more than 250 volts down here, I got more than 1,000 volts on the top side. And that's outside my meter rating. I need to know those things. What if the label's gone, and a lot of them are gone out here? How would I know which side's which? I've got them mounted upside down more than once. How do you know which side's which? And they're kind of expensive to replace, about 200 bucks a piece now. Let's go get one. Got to change it out. Time. So, I can check it. Don't trust the jumper. Number one, that jumper will fit right here. It could be on either side. I've seen them on both sides. So, I'm going to take the jumper off. On de-energize the system. Turn the power off. Take off the jumper. Okay. This is H1, H2, H3, and H4. H1 and 2 are a coil. H3 and 4 are a coil. Okay. We'll go H1 to H2. I should get an ohms reading. That's the first coil. H3 to H4. I should get a resistance reading, ohms reading there. From H1 to H4, I should get infinity, an open circuit. That tells me immediately this is the high voltage side. Take my reading on the opposite side, no matter the orientation of the transformer. Okay. Takes what, 5 or 10 minutes at the most? Probably take longer to walk back and get your screwdriver, take the jumper off, and do the readings. Okay. Then there's no doubt of which side to take first. Always check the secondary side first. We'll wrap up this morning with rescue and release. Okay. To remind you a few things you need to remember about rescue and release if it comes up here. Anytime you got to call 911 for any reason at all, from your home, from the highway, from the job site, that 911 operator gets on the line with you needs to hear 3 things quickly, and preferably in this sequence: what you need, where you need it, and the situation. I need EMS at this address for field wreck, gunshot wound, knife wound, dog bite, whatever it may be, or electrical injury. Okay? What you need, where you need it in the situation. Okay? That gets help to you on the road as quick as possible. If you start telling them man down or injury or whatever it is there, they got a list of about 40 questions they can ask you. You'll start going right down that list. Okay. If I call for an ambulance on a job site, when did I need the ambulance there when I called? How about before I made the call? I really needed them there 10 or 15 minutes before then, didn't I? Okay. Don't slow things down. Tell them what they need to hear, the sequence they need to hear it, so things move smoothly and they get there as quick as they can. Okay. What you need, where you need it in the situation. Okay. If it is you and the victim only, and you can shut the power down first, then proceed calling help. Okay. If you cannot shut the power down for some reason, first thing you need to do is get help on the way. At least someone now knows there's a problem at that location and help's headed that way. If you get involved and being executed along with them, at least help's on the way. May get there in time or may not, but at least help's on the way. If you don't do that and you touch them and get involved in it also, you can't call for help. It's over with. Okay. But if you turn the power off, do that. If you can't, get help on the way. Anything you do past this point, you can't turn the power off, is now more dangerous to the person doing rescue. Do a real-time, quick risk assessment. Don't get locked in electricity only, okay? Think about other things there. Maybe impedes you getting to them. Maybe other equipment in the way. Maybe things you need to clear or shut down first, okay? Don't injure yourself. You can't help them if you do that. All you're doing is guaranteeing their death also. So do a quick, real-time risk assessment. Look for any problems. For the victim, time's critical. Within 4 to 6 minutes of oxygen flow to the brain damage can start occurring. Okay? You got a 4 to 6 minute window before it starts occurring. After 6 minutes, it is occurring. After 10 minutes, whatever's happened is irreversible. They can't change it. Okay? So for the victims, time's critical. Have you been through CPR? Have you had CPR training?
Yes. Yes.
Okay. They've gone to compressions only for non-trained people. They need to clarify that sometimes. It's non-trained people. They've gone to compressions only. Okay. How long can you give CPR even doing just compressions? How long do you think you can go? No, the book says to help arrives, right? That's what's in the book. I don't live in a book world. I live in the real world. If you're by yourself and it's you and the victim, how long can you keep him alive?
10 minutes?
National average is 5 minutes.
Well,
That's the national average. Some people a little bit less, maybe 7 or 8 minutes, maybe 10. Some people in really good shape, pushing really hard, adrenaline flowing. You might can go 8 or 10 minutes, maybe. Okay. Most likely not. Okay. I guess Bob Vince say, well, Dan, sorry, man, did the best I could. Right? How far away are you from help? If it was you and the helper only on a job site, how far away is help?
15 minutes.
That's too long. I had that happen to me when I was a foreman wrapping up a job one time doing punch list. The helper they had with me was 55 years old, almost 56. I was in my late 40s. He was my helper. Okay. He went down, and I'm doing CPR on him. And I'm thinking about one thing only. One thought in my head was this: 4 minutes. I remember that 4-minute window. Okay. I'm thinking, whatever I do, I've got to keep it within 4 minutes. Whatever I do to keep him alive, I've got to do it within 4-minute window. We're 20 minutes from help. Best case. They can't speed down the road to get to it. The road has got to be potholes and things in it. They can't speed and get there. We're 20 minutes from help, and I know that. Okay. How do I keep him alive for 20 minutes? I remember the 4 minutes. I did 2 minutes compressions. I rested 2 minutes. 2 minutes compressions. I rested 2 minutes. I stay within that 4-minute window. That's not in the books, by the way. No one told me I could do that. I knew the 4-minute window. That's what I knew. I knew they were 20 minutes away, best case. I kept them alive till I got help. Did it 2 on and 2 off, 2 on and 2 off. Okay. I was able to keep him going. I haven't seen that in the books ever. Have you? That's what I came up with on the spur of the moment, knowing that 4-minute window. That's why I came up with it. Okay. Just a thought for you. It worked. He had no damage of any kind. He survived the event. It worked. Sometimes it's not in the books. Luckily for me, it wasn't in the books. Luckily for him, I thought about it. This is a rescue hook. Yeah, yellow stick is worth 100,000 volts per foot. That's a lot of protection in electrical environment. Okay. With that hook, I can direct someone clear the equipment. I can jerk them clear the equipment. I'm putting it on the ground very easily. Okay. You probably won't find one anywhere in the field out here. I've seen 2 in 25 years here, both in classrooms for show and tell, not in the plant where they could be used if they were needed. Okay. And if you needed one of them, it'd take you 30 minutes to get to it. Okay. So it needs to be out there where you use it, honestly. I'd rather have it in the plant than in the classroom. Show me a picture. Put the real thing in the plant. Okay. You probably won't have one of these available to you. You should use a dry piece of wood, a dry broomstick like that to pry them clear the equipment if you can get into it to pry them clear. You could use a rope, a belt, or something like that also. Your virtual ready gloves. But all of those put you very close to the victim, do they not? Any accidental, inadvertent contact with someone's being electrocuted, now you're being electrocuted also. If you touch your elbow to them, bump with your knee, your leg, your foot, anything like that, you're both now being electrocuted. Okay? And leather boots don't protect you. They're conductive. Okay. These are very dangerous. I wouldn't say don't try them, but be aware of the situations. You have to stay completely clear other than what you're touching. I left in the class what's called a flying football tackle. And maybe because it's still in all the books. Okay. It is the most dangerous way to rescue someone. Okay. The key to a flying football tackle is the first word. It's called flying. I've got to have enough room to run, jump completely up off the ground, be in the air, hit them while I'm in the air, not them clear the equipment while I'm in the air, and while I'm in the air, still fall clear of them. Okay. The odds of doing that successfully is slim to none. I got 2 guys leaving on me. Donnie, y'all having to leave?
We had to get out of that office because they're having a meeting.
Got ran out, huh? We'll be done in about 10 minutes, man. They ran you out, huh?
Yeah.
Okay, the flying football tackle still in the books, but you got to be in the air the entire time you're doing anything. You got to knock them clear while you're in the air and fall clear them also while you're in the air. That's hard to do. Okay, particularly if you don't play tackle football all the time. Once you get them clear, you need about 5 or 6 feet from the equipment so EMS can get around them and do what they need to do. Now you start CPR, first aid, whatever you need to do with them. Okay. When EMS gets on location, answer their questions and shut up. Okay. If they need your help, if they have questions, they'll let you know, I promise you. I've met a lot of EMS people over the years. I got a friend whose daughter's an EMT. They're not shy, not one bit. If they need help, you'll know about it. If they need questions answered, you'll know. Believe me, they'll let you know that, okay? The victim's best chance of mental damage and surviving that event is let the people trained to handle the situation do what they're trained to do. EMTs are trained to handle the situation, okay? Let them do their job. Get everybody else up, get them to disperse and get out of the way. Don't distract the EMTs. Let them do what they're trained to do. The worst thing on a job site, when a guy goes down, everybody wants to gather around the guys down, don't they? Break them up, get them dispersed, leave EMT alone, let them do their job. Okay. I'm going to bring my contact information back on the screen one more time for you here in case you need it. And I'm going to show you where to go to pick your time for hands-on for Friday. Okay. And I'll leave that there for just a minute or two so you can do what you need to do with it. Don't need that.
Hello.
Ronnie, you don't need to do the hands-on with me,
Okay.
but I do need your license number in the chat for me.
I did send it. I sent it a minute ago.
Where'd you send it to? It's not showing in the chat.
Oh, I messaged it to everyone.
I got it. Okay. It was up on the chat a little bit on me. I got it. I'll take care of your renewal this afternoon.
Thank you.
Yes, sir. Okay, let me bring up the internet here right quick. I'm going to show you where to go. Bring that over on the screen. There you go. Go to my website. Quickest way to get there is www.dandudley.com. That'll take you to the main page of my website. Okay. Right down here says choose your hands-on training time, that blue button there. Click it. That'll take you to another website to pick your time. Okay. Read the welcome message, please. Okay. If your time is 3 o'clock in the afternoon, I don't need you there at 8 o'clock in the morning. Wait till 3 o'clock. Okay. The odds of getting in early, someone missing their time is pretty slim lately. So get there 15 minutes, 30 minutes before your time. Let us know you're there. Okay. We're pretty close to time most of the time. Okay. Get rid of the box. Exit it down. You see December 2025 hands-on training. Click it.
Yes.
You may
sir.
see instructors, me and Carlos Vasquez may give you instructions also. Go down the line here,
Yeah, I
keep
hear
that
that.
time that's available. Okay. Looks like my classes yesterday and the other day, I've already picked a few times here. So if it's green, it's available. If it's not green, it's not available. I can add an hour and a half or 2 hours if I need to time. After that, I got to clear the area when I'm doing training. Okay. And I'll show you in just a minute here where we're doing the training. Didn't need PowerPoint. That's what I need. Right here is the location for the training. I'm in a meeting room at the Fun Dome, which is on the loop on Business I-20 here. I don't see the meeting room hardly ever. It's got coffee in there, donuts and everything like that for you, and access to a restroom in case you need a restroom while we're there. Okay. Where it says truck and trailer location there, right up here, that's where I'm going to be. Okay. Once in a while, there's a semi-truck parked here in the morning. I may be right over here beside it here, but I'll be right in that area. That trailer right here, what my trailer looks like. My truck is skinned the same way. Okay. Should be pretty easy to find me. Okay. Park your vehicle out here. Do the hands-on training trailer. Okay. I'll meet you at the trailer, not at the meeting room. Last month, I got with you 3 hours in the meeting room. In fact, I told him, I'm not going to walk back and forth and find you and bring you to the trailer. I'm not going to do that. Okay. So I see there's coffee in there, water and stuff in there, donuts and stuff in there for you. I'm not going to come out. I hardly ever see the meeting room. Okay. So meet me out here. Any questions on where to go or where to go to pick your time?
No, sir.
I'm trying to make it easy. Sometimes it seems to make it hard, though. I'm trying to make it easy as I can. And that way you're not there all day long waiting on your time.
You see a 2:30 to 3.
You shouldn't have to be on location more than an hour, roughly. From the time you get there to the time you're ready to leave. So that's the plan for it anyway. My cell number's on the bottom of this screen right here. It's the very bottom down there. So my cell number's there. If you get lost, give me a call. I actually had a guy pass my truck and trailer 4 times the other day. I saw him go by me 4 times before he realized I was right there beside him off the road. So you got to open your eyes. I'm fairly easy to see once you get to the location. Any questions on anything we talked about today before I let you call it a day?
No.
No, sir.
How did the morning go? By the way, that's what my truck looks like. It should be pretty easy to see my truck and trailer. Yeah. How'd the morning go for you?
Very good. Thank you, Dan.
Yes, sir.
Real good.
It was
Very
good. Thank you.
Gentlemen, y'all be careful. I see you Friday at the hands-on, whatever time you come in there for the hands-on.
Yes, sir.
If for some reason it fills up, let me know and I'll add some. I can add an hour or 2 to it if I need to. But I can't go past 7:30. That's my time allowed I'm paying for on that location. So if something goes on like that, let me know. Otherwise, I'll see you Friday. Okay.
Thank you, Dan.
Yes, sir. Y'all
Thank
have a
you.
good day. Be careful out here.
Thank you, Dan.
Yes, Ronnie. I'll take care of your renewal this afternoon, Ronnie.
Thank you, sir. Appreciate
Yes,
you.
sir. You have a good day. Good seeing you again.
Have a good day.
You too, man. Gentlemen, the leave button is the bottom corner of your screen. That's how you escape.
Sir?
I'll tell them how to escape, Ronnie.
Oh, okay.
The bottom of your screen is a red leave button. You see that leave button? That's how you get out of here.
Which one?
Click it. Bottom corner, I think it's the left corner or right corner of your screen. I don't have that leave button on my end, so I can't show it to you. Well, on my iPad, it's a little X, a white X with a red hexagon around it, says leave.
Oh, it says leave?
Yeah, it says leave, L-E-A-V-E. See it?
At the
Just click it and it'll pop up and say leave meeting.
I'm looking for it.
Bottom of your screen on the menu. Where the chat button is on the right side of that menu.
Oh, I got you. I got you.
There you go, little X. There you go. Bye, Ronnie.